Well, hello, Mo.
Hello, Leighton. How are you today?
I'm doing well, buddy. And yourself?
I'm doing well, too. Thank you.
Yeah, so it's been 2.5 years, almost to the date. Since we
God, where'd the
started
time
working.
go, huh?
Yeah, God, right? And the audience, both Ken and the audience, are very excited to hear, what ground we've covered. So let's start by reintroducing you because it's been so long.
It has been a while.
Yeah, and this guest, we have different people listening now than we did back then. So why don't you give us your backstory, just for the audience to know?
Well, my name is Mohammed Memon, or Moe, as I'm commonly known. I'm the CEO of Ecosphere Sciences and the primary inventor of the Muncher that we're going to be talking about in the show today. And I started working on this project many years ago, and I came together with my team to scale it up. And actually, part of what we'll be looking at today is my original test unit that I built in my garage at home and started the whole process with. So we're going to have a little fun with that. We're going to show a little, I think, a 2 or 3 minute video that Ken will have queued up at some point. We'll kind of give you a little explanation of the Muncher itself and what it does. And then we're going to, I guess, Leighton, you and I can talk more about what we've been doing these last couple of years.
Yeah. So, again, the driving factor behind this was a tragedy that really got under your skin to a point where you never quit. And that's just an incredible story. The fact that you just ground on and on and on, even though, you didn't know if this was ever going to come to this point. So,
yeah. Well, actually, I'm doing a project up in my mother's my hometown of Kingsburg is where I'm actually working right now, and it's kind of surreal to be up there doing that. And as you know, Leighton, and people here on the show may not know, my mother died of cancer at the age of 47, and it was largely attributed to exposure to chemical fertilizers and pesticides and things that were very common in farming back then, and unfortunately still common today as well. And a lot of people in her area died of these unusual cancers as well. So the motivation is to do something different to encourage coming back to like a more natural, organic form of fertilizing the land and growing crops, regenerating the damaged soil, making it healthy again, restoring the biology, which we can do.
Yes, I had no idea that that's where you grew up there, right?
I did not grow up there. My mother and father met there, and then they moved down to Los Angeles. I was actually in LA. And then at the age of 4, we moved a little farther south and came to Huntington Beach, where I currently reside.
Gotcha.
But I've been going up there to the Central California all my life. My mother used to take us up there all the time to visit her old friends, and we had a lot of family up there for many years as well. So
we lost you, Mo.
Did we freeze? Oh, no, there you are. Okay.
Can
you see me again?
Yeah, we can see you fine. Just repeat that last 2 sentences because we lost you.
Oh, yeah. No, I was just saying that, I've been going up to the Central California area most of my life because my mother would take us up there whenever we would go out on trips. We'd go visit her friends, and we had a lot of family up there for many years. Everyone's kind of dispersed now because I don't have any family that's still currently farming, but that was how it started.
Wow. So ironic that you ended up back there.
Yeah.
Right. Or maybe it's fate. Maybe it's
maybe I think so, and that we are, accomplishing the things that we are. I think maybe we're just coming full circle.
Yep. Yep. So are we allowed to talk about the work you're doing with Matt, or should we just instead of going?
We can talk a little bit. It is early yet. What I could say is, he is this gentleman Matt that I'm working with up in Central California is he's a generation farmer, and he has been just step by step systematically working towards making his farm natural and organic, and he's been stepping it down gradually as he's been improving his soil health and just making everything better. He does his own composting, makes his own compost teas as well. He has a whole way of brewing the stuff, and he's getting very good results. And right now, with the Muncher juice that we're generating up there, we are already seeing some good results. We're doing a test in part of his land, and it's early, so I don't want to say too much yet, because we've just started the testing there, and we have I want to accumulate some data before I really get excited. But what we're seeing so far is already exciting.
Well, that is the common thread. Ever since I met you guys, you first brought the machine down to Peach Hill, it was like, oh my God, you did it.
Yeah.
At the end of the day, I kept telling you that you can't do this. It's impossible. And you did it.
Everybody was telling me that.
Yeah, I'm sorry to be the last asshole to say it. I am proving you right beyond a shadow of a doubt.
Yeah. Well, and it's nice to see the Muncher working, the process working. And the only thing that, can stop it is when something really negative gets introduced into the process. Like, when we were at Agrimin and we processed a high volume of lemons. Lemons are problematic for bacteria. And, we have a bacterial transformation process in the Muncher. So if we kill the bacteria, well, we mess up the process. But then, by moving around material a little bit and saying, okay, we're going to process more of this and less of the lemons and stuff, we figured out how to overcome that and ended up being able to process anyway. But things like that, can cause issues if the system becomes too acidic, is another thing. So, we buffer the process with calcium, to help maintain that. There's a few interesting things like that we encounter. But for the most part, it took a few years, and we have now figured out pretty well how to keep the reaction going and to just process like gangbusters.
Nice. All right. So let's start with the picture. I
Okay.
saw this for the first time yesterday, and I was like, oh my God, you're an animal, Moe. All right. I'll let you play it.
Yeah. So this, what you're seeing here, this is a 30-gallon barrel, and this is what I made the first solid waste processing from. The initial stuff that I did was just through water treatment, and it's kind of boring to see that stuff, because literally it was just water being dripped into a tub. So this is where things really started to happen when I built this machine. And this is the cornerstone of how you see that's the initial grinder that I'd grind up waste with. And what we would do is, grind up waste, put it into the 30-gallon digester, mix, with the water, and I had a paddle system in there. One of the photos here is going to show the inside of it. There you go. So I welded all of that stuff together. I do welding and metalworking, so I made this entire thing myself. And just from there, started changing everything from, there's heat, agitation, aeration, and you can see also the screen that's inside there that material would come through as it was processed, and then there's a drain on the bottom. And that's what I started doing, is just experimenting with a lot of different biological mixtures and formulating the correct bacterial mixture, getting the proper level of heat, getting the even just the RPMs, the level of agitation with the with that shaft. I just would every day, every few days, every week, depending how things were working, I would go through and say, okay, we're going to increase this by 1 RPM or 1 more RPM or 1 more, or slow it down a little, add a little more heat, a little less heat, add some more powerful aeration, and just through trial and error, just kept grinding on it. Because what would happen in the beginning is I would work for a while, the reaction would go, and then within an hour or two it would die, and then it was a matter, okay, how do we figure this out? What's going on? Why did it stop? And just by continuously tweaking the system, and just through a long series of, obviously, a lot of research, a lot of trial and error, figured out how to make it work, and the ideal temperatures and all the factors that have now led us to the larger system that we currently have, the one we took to Peach Hill, and is now at the facility up in Central California. And this is the larger system on the trailer. We've got a big grinder at the front again. You can see a little bit inside the trailer. We've got the initial soaking tank or homogenizer, where we send the waste into initially to establish the liquid solid ratio. And there's me in front of the machine. And then from there, the material gets pumped into the main digester that's also inside the trailer. And we have a video that we'll get to see coming up here shortly. And we'll see what it kind of takes on a little tour through the Muncher.
Nice. So another part of the what you call pre-digest is also to get that material very hydrophilic so that it is ready to process, correct?
Correct.
And one of the other interesting questions would be like, well, where did you even start with the biology, Moe? I mean, that's a brainy subject in itself, and you did this 15 years ago before a lot of the real good information was being released from the ivory towers, the universities, and colleges.
Right.
So where did you start?
It was I wanted to process quickly and without the dangers that are associated with, like, the anaerobic processes, for example. Mm-hmm. And I ended up looking at the nitrogen cycle and saying, okay, I want to process aerobically, and just literally just started studying and reading, and just kind of found out, okay, there are aerobic bacteria that can possibly accomplish this. Of course, everyone was telling me, no, you can't do it. It has to be, anaerobic. But I said, no, I think this can work. And I just started researching, and buying different strains of bacteria from various companies that manufacture it. And I just kept mixing and trying different things, and also experimenting with different types of nutrients to help the bacteria stabilize and thrive. And it was just years of learning and trial and error.
Well, kudos for you for never quitting. Seriously, a lot of people would have given up.
I believe me, the thought has crossed my mind a couple of times, but the mission is to change the farming practices and a number of other things that are poisoning us. And that's a powerful mission to have, I think. And I just you just can't stop. I mean, because if we fail in this, where do we go?
Dude, I had the same experience in my life. It was, trial and error, beat your head against the wall. And finally everything clicked. And then you realize, oh my God, this is amazing. There's no limits to this. Right. Everybody needs this.
Exactly.
And that's like, where do you even start in marketing? Like, I chose landscaping because I figured, well, landscapes are always around streams, ponds, golf courses, stuff like that, where if you could get the biology in the soil to start cleaning it up, that would be a great place to really start. And no matter how discouraged I got, no matter how beat up I got, no matter how times the equipment broke down, or dude, how much have you worn, right? Like I've worn so much compost extract.
Oh yeah.
It's so scary.
I agree. I couldn't tell you how many from the compost itself, the liquid, the slurry, getting sprayed with it countless times. The worst ones have happened though when occasionally I was up working on a scaffolding, putting material, and sometimes one time I forgot to cut slits into a bag that I threw in, and it had rotten, nasty fish and guts and all this stuff that was in it. And that thing just exploded all over me. And I'm stuck on this little scaffolding. I couldn't get out of the way. So I just kind of, and actually had a group of people from the waste industry were there watching that demonstration. And, when you gag the garbage man, you really know you've accomplished something.
Oh my God. Yeah, dude, I had a similar one. In the beginning, I was working with extremely anaerobic fish.
Oh yeah.
Like, if you got it on your clothes, you had to throw them away. I don't care how many times you wash them, forget it. And if you got it on your skin, it was 2 to 3 days of heavy washing before you finally began to smell like a human again.
Yeah, it's really interesting. The film, the biofilm that comes out of that stuff, I swear it just absorbs into your skin and and just becomes a part of you for a while.
Yeah, I can't think of a better way to describe it though. It literally sinks into your skin.
Yep.
And you smell like that for days.
Yep. Exactly.
So, funny war stories, buddy.
Oh boy. Well, as we're going, shall we pull up that video and take a little tour inside the Muncher?
Let's do it.
Yeah. Welcome to the Muncher, Ecosphere Science's totally aerobic waste processing system. My name is Moe, and I am the CEO of Ecosphere Sciences. I'm going to take you through a tour of the Muncher unit right now. They begin with grinding material and setting it into a conveyor where once the material is ground, it goes into the secondary grinding system. It is then set to the homogenizer where material is further ground down, and we establish a liquid-solid ratio where we then prepare to send it to the digester with the grinder pump that further macerates the material a third time into the digester where it goes for final processing. And we have a combination of heat, agitation, aeration. Everything is controlled, maintain pH levels neutral between 6 and 7. The process runs for about 45 minutes, and then we output from the digester to the collection system. Material comes out here into in this case, the blue barrel for final collection, and the remaining liquid that is super oxygenated and microbially enriched continues to recycle through the system to help maintain the reaction. Now, the reaction is, again, totally aerobic, and we are continuously breaking down material, creating an ideal environment for the bacteria to survive and thrive and just continue to rapidly break down the waste. The collection case here is a tote where we pump the material here for final collection. In this case, it's just like a liquid slurry. Material, depending on client's needs, can be separated into liquid and solid, unless you have more of a T and solid outputs. That just depends on the end desire. In this case here, we have some totes that have already been filled. Now, these are going to be used in a test process out here at Agriman, and we will be experimenting with compost to see about enriching the process that they're doing here. Now, as we are continuing around the system, part of what we do, since we are processing totally aerobically, we maintain a buffering system where you have a combination of calcium liquid here, in this case, that goes into the aeration system, which maintains the process and keeps our pH in balance. And if you follow me up here, you get a little view inside. And you can see the aeration system and see the process in action there. This is the liquid that is just continuously cycling through the system to maintain our reaction. If we don't see bubbles, then we're not working. And that, basically how the muncher works.
Very cool video, dude.
Yeah, thank you.
Yeah, that's great work. So since we started with agreement, or you shot it, you know what? Let's rewind it all the way back to Peach Hill, because again, the audience didn't live this 2.5 years with us. So
right.
One of the very first tests I did was just take the muncher juice and throw it on compost and determine what happened. Remember that? And so what I noticed is, as the volume of muncher juice went on, it lowered the temperature and slowed the composting process. And that's what started it. And I was like, oh my God, something really interesting is going on. That led to playing with ratios, obviously microscoping things, realizing that you have protozoa, you had nematodes starting to come out. So you were stirring what we call the necromass. So the necromass is the things that are asleep. It could be bacteria, it could be nematodes, it could be protozoa. It could be endophytes that were part of the plant before the plant died. So, you know, again, that was like this, oh my God, this is, what have you done, Mo?
Well, and interestingly, you know, I also at the time did not realize how deep into the process we had gone. And just as we've been over these last couple of years, especially, we've really learned so much more. Because I really, you know, in the beginning, I was like, okay, we're breaking down this waste and turning it into this great product. But as we've come to learn, we're doing so much more than just that. And as we've been seeing with, as we've tested with a whole series of pesticides that came up negative, various other toxins that have been able to be broken down by the bacterial action. We're just discovering more and more. And again, besides just being able to turn this waste product into a useful commodity, it has tremendous benefits for the environment, for being able to restore damaged soil, to do environmental remediation projects. There's benefit after benefit.
Yeah. So before we get down the rabbit hole with Primus, do you remember? I think it was your second time back at Peach Hill, and Ron had connected with a cannabis company that destroys the cannabis. So after the expiration date, or say it doesn't pass its pesticide tests, whatever, it's now considered a toxic or hazardous.
It's basically handled like a hazardous waste product. Yeah.
Right. So you guys brought up, oh God, buckets and buckets and bags. Everything from processed flour to pre-rolls to I think there was like some hash gummy bear things in there. I mean, it was everything. It was
all the different types of waste that you could get from the process. And but they're obviously even if these things expire, you can't just throw them away. Like you were saying, they're basically treated like a hazardous waste product, and you can't just dump them in a landfill or anything like that. It requires special handling. And so one of the things that we were asked is, can we process this? And I said, well, we've never tried, so let's do it. And so we put it through the system, and we processed the waste that had a certain level of THC in it, that was above whatever is allowed, to be just disposed of normally, and we brought it down below the limit. So that that was quite an accomplishment there, and I was very impressed with that.
So we we stunk up Peach Hills like it was a ring.
Yes, we did.
Oh my God, I could smell it coming down the road. I could smell it up top. I mean, it was crazy how pungent that was.
Yeah.
And so the THC prior to going through the process was at 27%. And when it came back, it was 0.03, I believe. So,
that sounds right. Yeah. It was below the level that is required. So we definitely accomplished the objective on that.
And I think the other really cool anecdotal or anecdote that we collected as a result of it was that even after it was processed, I was blessed because you just let me take whatever I want, play with it. So I took pretty much most of this cannabis related stuff, and I brought it back and started playing with it, microscoped it, etc. And ironically, it even kind of still smelled like cannabis. It wasn't as pungent, but it had that like funk to it, which was
had a little bit. Yeah.
I did not expect that, but needless to say, I sent it to a buddy of mine who's a hash maker. He's been on the podcast before, although he likes to keep his name out of the public. I told him what it was, and I said, I've always known and preached this, that the best plant food for a plant is its plant, right? Because that's what happens in nature. It drops its leaves, those leaves spill the soil, spring comes around, it helps to boost the plant back to life. So I told him about this, and I said, hey, you want to try it? And I actually sent it off to 3 different people, and all 3 of them had incredible results.
Yeah.
And I think that, Billy's story is probably the most important because he had this cultivar that was amazing. It was the most difficult cultivar he'd ever grown in his life, and it was just finicky as all heck. And so the mother plant had 5 leaves. All the babies or the clones only had 3 leaves. And when he applied that particular MJ to one of the clones that only had 3 leaves, within a few days it had 7 leaves, which just showing incredible fertility. The mother still only ever had 5 leaves. And so he let it go all the way to fruition. The plant wasn't as tall as the mother. It was as tall as the other clones. The THC came back a little bit lower than expected, but the minor cannabinoids were through the roof and the terpenes were through the roof. So it wouldn't have been a great plant for him to sell commercially because it didn't have as much THC. But personally, when I consume, I like the lower THCs and I like the cannabinoids, what we call exotics and the high terpene profiles, because they really create this, entourage effect. And so I did have the pleasure to try some of it, and it was amazing. And he made some incredible hash with it.
Nice.
That was like the first time I realized, holy shit, you got metabolites. You got secondary and tertiary metabolites, which stimulate what we want to call full plant genetic potential. And that's very difficult to do. I mean, even the work that I do, worm castings, fish brew, and my own biologically intensive compost, it's taken me years to get that formula to the point where I can get the plant to express that. And it's usually not on one application.
Right.
It takes like the first run is okay. The second run, you're really starting to see it evolve because now all of the ecosystem in the soil is really starting to function properly. And then by the third run, it's all off the top.
Yeah.
So for you to do it in one.
Yeah, I've and again, it's just like you. I mean, it's many years to of testing and trial and error to accomplish this. But one of the things, like if you look at various products out there today, they'll say, "Oh, we have 2 or 5 strains of bacteria," and it's like, okay, well, I mean, I've got hundreds. There's so many, and the synergy that they have, there's just so much going on there, and you'll see on packaging of various compost products, like, oh, we've got these 2 strains of bacteria in here, and this is so great, and it's like, well, yeah, okay.
We call that bugs in a jug.
Exactly.
they're manufacturing these bugs in a jug in the absolute perfect environment.
Right.
But you have communities, right? So
Correct.
you're what we call in vivo, so in nature, in relationship, whereas theirs are grown individually, perfect food, perfect temperature, perfect everything, and as soon as you take them out and throw them into the environment, you'll get you'll get a short burst, but they're not an inoculant. You have to keep using it over and over again.
Well, I tell people, you could take my biological mixture, and you could put it into, let's just say you put it into a solution, and you could shoot it on, onto something, into something. Whatever. It's not going to do much of anything at all. You have to go through the whole process of breaking down this waste, and the bacteria itself changes with that process. And you probably have more ways of explaining that, but the changes, the transformation that it goes through as it's adjusting to the waste that we are working with, the whole thing there is what creates the magic. It's the whole process together. And like you said, if you did this in the laboratory under these ideal conditions where everything is so perfect, then when you get it out there into the real world, and you've got it's hot, it's cold, it's whatever things going on, and it doesn't survive.
No, it becomes a biostimulant, to be honest.
Mm-hmm.
It's not an inoculant, it's a biostimulant. So whoever's there, they'll function for a certain period of time, but whoever's there is going to end up consuming them, and that's the end of it. Yep. And this goes back to one of the early tests. I think it was maybe 6 months into it, where we plugged in with biomakers, and I sent off samples. We were near the water. Is that true, Leighton? Or we were processing. Who we were processing for?
Was that with writers, or was I'm trying to remember which one because we.
No, it was the one that the system got unplugged, and I was.
Oh yeah. That was at the cannabis processor that was up there north, up in Northern California.
Yep. And so I took the samples, and just for goose and giggles, I took one from the bio bed, aeration
from the aeration tank,
and then one from the blue, your output tank.
Mm-hmm.
And when the results came back, which took a while, I think it was probably 2-3 months before we got those results back.
Yeah, I remember
but they were radically different, like radically different. And I was like, how is this possible? And that this is this was happening over and over and over again. Everything that I explored with you was like, this is impossible. How can this be? Because you're circulating everything through the whole system constantly to maintain that reaction. There should be no variation in the different tanks. And that was just another moment. I was like, oh my God, you really created a phenomenon that is going to take a lot of time to really unravel.
Yeah. And again, too, like I say, we ended up really discovering that we've done so much more than we initially realized. And I think we're still discovering these things, and especially the work that you and Craig have been doing, our science team, that we're discovering more and more amazing things about this. I think almost on a daily basis now.
And there will be more, because we have so many balls in the air right now. As those start to fall down and we start to get the data or the metadata and start plugging it in and sussing it out and opening it up to a bit deeper understanding, because again, they're all connected. So it's like you have to take a step before you can take the next step. So fortunately, we've been blessed with kind of an open budget to take those steps, so that we have everything ready, so that we're ready to take the step. That information has been processed, and we can now start to suss it out. So, and another thing too that kind of keyed me into that you had gone beyond NPK, and that's something we really need to talk about.
Oh yeah.
But you with the anecdote or the pictures of the artichoke. Now this blows me away. I want you to talk a little bit about that test,
Sure. So we took 2 artichoke plants, planted them at the same time. One was treated with the Muncher juice, and one, just watered normally and everything. All else being the same, they were both watered regularly and just treated. The Muncher juice treated artichoke plant produced 7 artichokes, and the non-treated one produced 4. So it was, again, just to show the power of the Muncher juice and the effect that it has, on these things. And besides, not just on artichokes, I've done it on leafy greens. We have brought trees that were just virtually dead back to life. We just actually, one of a gentleman that we work with up in Central California, we put Muncher juice on his orange tree that was just gone. He was going to just have a crew come in and just take it out. It had no more. The branches were gone. It was just virtually just dead. Put the Muncher juice on it. He's now. This has been. I think I put it on there about a year ago. It's producing oranges again. It's completely grown back.
Again, the healing ability is just incredible. These were the kinds of things that were like, the more you would tell me, like the other one was the avocados producing in half the time they're typically.
Yeah, we did the test down in Mexico City with our partner in the company down there. From seed to small tree bearing fruit, it started, or avocado is a fruit, I believe in it. I'm forgetting, but it within 18 months, we're growing avocados, and normally it's anywhere from 3 to 5 years for an avocado tree to start producing. So that was that we felt that was, again, pretty amazing, and we're seeing that kind of activity. I have my own personal avocado tree that I've had for over 50 years at my house, and it produces avocados 2 to 3 times a year,
which is unheard of.
Yeah,
it's usually every other year.
Yep.
And so these kinds of pieces of information just kept coming and coming and coming, and it was like, God bless it, man. Where do you go? And it got to the point where I think it was about a year, or maybe not quite a year, maybe 8 months into it, that I had no choice but to say, all right, guys, we really got to start looking at the DNA, because we got to figure out what's going on in here. And I don't know whether it's all horizontal gene transfer or biosymbiosis between the bacteria, but it's definitely something more is happening than what you used to initially start it up. It's just growing and expanding in ways that are completely mind-blowing. So that's when I called in Craig Trester. He believes he's been on this podcast.
He's been on the show, yeah.
Who's been associated to bioinformatics. He's a mycologist, and he'd been listening to me tell stories about you and the Muncher for like 8 months. And I'm like, dude, I can't really take this. I need a team. I need some help here. There's a lot more to this than meets the eye. And so we pretty much got him on board. It took him a while to catch up, because again, we were traveling at the speed of light. I hadn't had the opportunity to communicate everything, and I needed you to communicate what you'd seen for the past 15 years. Right. So we more or less had to waterboard him, which he enjoyed.
Oh yeah.
And so that led into the berries. That was right around the time we were at Bristol Riders. And I remember talking to the gentleman up there, which I probably shouldn't use his name, because we don't have a release from him, about what was going on. And he was explaining to me, well, we got a couple of different problems. Number one,
right,
when the berries that have been attacked by a bacteria or fungi are either dropped or picked by the planter or the pickers, harvesters, and thrown on the ground to rot. Right. They're just spreading the disease all over the place. And that's requiring us to use even more and more amounts of pesticides, biocides specifically, to manage this problem. And of course, as you manage biocides, now you got to deal with herbicides because you're going to have other pressure from other plants that are trying to tolerate this horrible environment. I mean, dude, I'm reading articles on plants right now that are just mind blowing. Like, they know what's going on. They chemically talk to each other, and they come into an environment to clean it up because their whole purpose on this planet is to push succession. So from, you guys all call them weeds, I call them indicator plants. Push from indicator plants to conifers. I mean, that's the goal of the whole plant ecosystem. So then pushed it a little bit further and said, well, what happens to all this stuff? And he goes, well, it kind of builds up in the plants themselves, and we're forced to, pay extra because, again, it's being treated as a hazardous waste product and not just a plant matter. So they can't compost it.
Right.
And so then, like, the aha started going off. Like, okay, and I should back it up because you guys did some preliminary research that we're going to verify coming up soon. Why don't you talk a little bit about the glyphosate experiment?
Yeah, so that was another one that we did down in Mexico, where we did a low, medium, and high concentrations of glyphosate being tested in it. We have a smaller test system down there, and ran it through that unit, and in all three cases, a low, medium, and high concentration, neutralized it, completely broke it down.
Yep.
So that was one of the early things where we're like, okay, this again, onto something here.
Don't know what. And again, all of these are going to be all of the tests that we've done on specifically bioremediation will be done again, so that there's no shadow of doubt that the claims that we make are valid, and that's just going to open up doors to just unimaginable amount of work. But needless to say, so fortunately, the gentleman that was working there was able to slip us a test result after Moe had processed what are called canes. Now, canes are really root balls and stalks. So these poor plants are basically put in a pot where the roots grow out of the bottom of the pot into the soil. And this is legacy chemicals in that soil because they've been planted and they were living in this or reusing that land over and over and over again for generations.
Right.
So bottom line, it was like, okay, there had to be some legacies as well as whatever they've been using to try to take care of these plants so that they'll at least produce something. Because again, they pump them with NPK, and after 2 to 3 years, they die. They've killed them. They're spent. There's no life left in them. And so Moe fed a bunch of root canes and berries, which of course are going to have some expression through the Muncher process. And once the test results came back, there was non-detect on 352 individuals, 8 classes of compounds. So this is a full panel, man. There's everything that was possibly could be tested.
Yep.
And this is required by law because they have to by law maintain a relationship with the lab, with the governing bodies in California, so that they can then decide how bad this is and who's going to be required to take it and handle it. So they can't skip out of this. They can't dodge this. Now, unfortunately, they would not release what was put on the plant or what they find in these tests. So we don't have the exact compounds that we neutralized, but we will get that in the next series of tests for sure.
Yeah.
So that was another point where it's like, oh my God, if you really can bioremediate, and this was parallel while I was working with Rocketdyne or Santa Susana Field Lab. It was literally the same time, and I'm like, I have access to this product and this machine that you could technically, we could do a 1 acre plot up here and really, document what happens. And the woman that was there at the time was all excited. She was running it up the chain. And then all of a sudden, Boeing started suing NASA. NASA started suing Department of Energy, and Department of Energy was suing NASA. It just, everybody started suing themselves.
Yeah.
And so that everything went dead up there. And then I think it was about a year later, so that would have been just a year and a half ago. I went back, and the woman that was there had quit because of all these suits. She's just like, this is ridiculous.
Yeah.
But the state stepped in 6 months later and said, okay, you guys are not going to be allowed to just sue each other into the future forever. And you're going to have to get your act together. They implemented a mediator to sit down with the three main groups to talk about this. And they all agreed that, okay, yeah, we've been kicking the can down the road for over 10 years now, and we can't just kick it down the road for another 10 years.
Right.
Boeing agreed to do a further test study using bioremediation. The other two disagreed based on a failed test that had faulty experimental design. So the test was built to fail. And it was pretty obvious the way the test read. It was like, this is ridiculous. This isn't even close to the environment in which we're dealing with. It was in potting soil, right? Anyway, needless to say, everything started firing back up, and Boeing was gonna pull the trigger on a 1 acre bio and plant remediation, and then Trump took office, pulled the plug on a lot of money or started questioning it, and that got shelved. Then the wildfires came in, and so it will come back eventually in the future. But now that we're into Llano, it really doesn't matter because we'll have access to plenty of toxic hazardous sites.
Yeah, they're going to be doing more of that testing, and we're going to see again just to verify what we already know to be true, but we'll get that that additional verification from them. Yeah.
So Llano is Los Alamos National Lab. Ecosphere Sciences has entered into an agreement with them. We now have been assigned a primary investigator, and this is, you guys, this is my dream come true, because I used to do bioremediation back 10, 15 years ago now, and it was something that really made you feel good, because now you were actually repairing the damage of greedy companies and greedy people, and so it's not about the money, it's about doing the right thing, or maybe leaving something really good behind. But needless to say, so we've been assigned a PI, primary investigator. Craig Trester has been assigned ESS's primary investigator, and we've already had letters going back and forth. We've completed the entrance exams, the 3 different levels of it, and so we're in go mode now. And there were emails flying around last night about this, and I'm not sure you even know about this yet, Mo, because if you haven't talked to Craig today, then you wouldn't know.
Right.
But very exciting stuff. So the final, their final agreement to our desire to test in these 4 areas has been accepted. Our PI, their PI, has already contacted multiple parties down there, because he's going to assemble a team, because they're very siloed there, and it's kind of required by government work. But when you're allowed to partner with them, then the silos fall down, and the PI is allowed to pull from different groups to really explore this. And so the other interesting thing is they have what's called metagenomics, which is like the level above us. Like we're doing like more of a shotgun, where they've got a sniper rifle. And
that's a good way to put
Yeah, no, this is so exciting because you can target a lot more effectively that way. You're not just blowing a hole in something, right? You're nailing it, the head of the nail. And even more crazy, which I don't think we've talked about because we've been so damn busy, is that they have a pipeline. Now, for the audience, I know you've heard me rambling about this shit for long enough, but what the pipeline does is you feed in this data. All right, this data is ones and zeros, very complex, and it's non-human readable. And the pipeline starts to shift it into a human readable form. The pipeline can have segments added to it, filters added to it, so you can really begin to take the signal out of the noise. So it's like being at a rock concert and a jet airplane goes over the top and you can't hear the music anymore. Mm-hmm. So now we're going to be able to really pull the music out. And then with that information coupled with what I want to call the large learning or large language models, the chat GPTs and these other wonderful new AI tools. They're not really AI, they're LLMs, but a lot of other words. Now you can start to say, okay, we know this bacteria does this. We know this family of bacteria do this. But when this family and that family are together in the metrics, what's coming out of it? But it will suss all of this out. Yeah. You know, and we have 9 months for the rest of 2025, and then 4 more years after that we have established a contract with them. Can you imagine what we're going to be talking about? it's
going to be pretty crazy, that's for sure.
Yeah, it's going to take a lot of time for the information to come back. It'll come back in dribbles, but once we get like we talked about earlier, you know, one step at a time, but each step leads to the next step. And so when you get to, like I said, 2 years from now, we're going to be talking a whole other language, dude.
Mm-hmm. Yep, I agree.
All right, so let's get back to the real, you know, bioremediation is cool. I'm really super excited about all that stuff. But more importantly, let's talk now about food. And there's something that, you know, is really, really important that we don't talk enough about is nutrition and vitamins and minerals. And so your experience in things that you've consumed that were grown on the Muncher would be a wonderful time to, you know, chat about that a little bit.
Oh, sure. And actually, let me start with some more things that I've been talking about with the guys up there in Central Valley. So I'm 56 years old, and I've been going up there I went up there with my mother since I was a little boy. And one of the things that I was talking about with the people I'm working up there right now is that when we were all young, like oranges were the size of a softball on the trees, for example. Those oranges now are about the size of a baseball. And there's less nutrition in them. You know, I think the joke is that it takes like 20 oranges to get you the, you know, quantity of vitamin C and nutrition you used to get from one, you know. So that's a thing that we talk about. And, you know, the flavor isn't as good, doesn't taste good. When I grow food, any type of food crop with Muncher juice, it's richer, tastes better. You know, we're going to start doing nutritional analysis on these products, but you know, the plants grow stronger. They are more nutritious. And simply they taste good again. And I remember, and now when I grow those things, I remember saying, yeah, this is how these things used to taste when I was little. And, you know, you don't get things like that just in the grocery stores anymore. It's really crazy.
Oh. Okay, guys, settle down.
Poe's wanting to be part of the job.
All right, buddy? He just flipped off the back of the chair. He's all right. Yeah, and that's, you know, that's something that, like, I can't emphasize enough that you see so many people that are obese but malnutritious. nurtured. I mean, that's the opposite of everywhere else in the world. Like, you go to some of these other countries where they can't afford to pay for fertilizers and for pesticides, like Greece. I was over there a couple of years ago, and the food was just incredibly delicious, and I felt healthy and revived after the meals, not like kind of food hangover, like, right?
Yeah. Well, and you notice too when you're in those places like that they just don't have the level of processed foods that we have here, which again, there's less nutrition, and they're causing us damage as we do. That's a whole other rabbit hole we could go down, but I don't know that we want to do that right now. But when you're growing things in a natural manner and you're not putting all this chemical garbage into them, you get healthy, nutritious food. Plain and simple.
Yeah, and the fact that this provides that, again, we probably should back it up, and I should be, explain what we've discovered so far, and that is that it is a bioinoculant. I've applied it on compost. I've applied it on soil. We actually applied it on sand. Grew tomato plants, which is something else we should talk about.
Oh yeah.
So we are a bioinoculant. So we know that the biology not only gets transferred into the soil. We even did this in a burn scar, guys. I went down and applied Muncher juice in Altadena on top of 3 to 4 inches of ash. And when we came back 2 weeks later, after 1 week, we had 8 protozoa per unigram. And it's a little bit more diluted than that. And week 2, we had 16. So not only did we colonize beyond a shadow of a doubt, but we colonized with something that could continue to survive and expand in that horrific environment. So we are a bioinoculant beyond a shadow of a doubt. We're clearly a biostimulant. When I've applied Muncher juice to my biointensive compost, I'm seeing similar reactions. I'm seeing expansion across all of the communities of the predators and the nematodes. So there's something in it, a food source that encourages the organisms to either come out of cyst, which is something that's important to say, to understand that these organisms are constantly going in and out of cysts, or so in and out of suspension. If it gets too dry, they go into suspension. If it gets too wet, they go into suspension. If the pH changes, they go into suspension. You spray something, they go into suspension. Suspension is how they protect themselves from not being eliminated. And so your product has something that chemosenses, or form sensing, that allows these organisms to say, oh, party time, let's come out and see what's going on. So it's got these biostimulants in it. We also know for sure that it's got these what we call secondary, tertiary metabolites. So that's like plant growth promoters, like in Billy's case. What is it called when they add more fruit? There's a bunch of different buzzwords, PGRs. There's a lot of them out there. But it has those characters on multiple levels. It's not just one PGR. It's got all kinds of different things. Again, expressions of terpenes. We don't even really know what species or family or community of bacteria are the ones that are directly related to releasing terpenes. And terpenes are critical because they're also bound to flavonoids. So that's what you're talking about with the oranges tasting better. So you're getting all of these interesting expressions, genetic expressions, genetic potential from the plant using it. And lastly, extra polymetric substances. So glomalin is a loose word that's been thrown around in science a lot about 15 years ago. Less so now. They're called soil-related glomalin proteins because it's not glomalin. It's glomalin when it's in the fungi, but as soon as it comes out of the fungi and goes into the soil, it becomes a protein. And the soil around it affects how that protein is folded or can fold. So why I'm saying that is because of the soil formation characteristics. When you apply that to sand, after a period of time, it becomes dirt. It's changed color, right?
We watched it happen literally right before our eyes.
Yep. So let's talk about the tomato experiment, because this is fucking incredible. Like,
yeah. So what we did is we did this in Laguna Beach, and we had a gentleman that we work with down there. We took 3 5-gallon buckets. Well, we had 4. One was just a bucket of sand that we watered as a control that did not have anything planted in it. But we took 1 bucket, we put tomato plants in it that we watered, no fertilizers or anything. We took 1 bucket that we put the plants in, and we put Miracle-Gro on it. And then we took another one with the plants, and we put Muncher juice on it. And we did 2 applications of each product. We did so 2 applications of the Miracle-Gro. I believe it was over a 2 or 4 week. I forget, I have to look it up, but either a 2 or 4 week period, we reapplied, for the second application, and then that was it. From there on out, it was just occasional watering, and the Miracle-Gro one grew. The plants grew bigger, produced tomatoes, and the hornworms just went to town on those plants. And the Muncher juice treated one made more flowers. Produced, the plants were a little smaller, but it had more flowers, and we did not produce quite as many tomatoes as the Miracle-Gro one, but the Muncher juice treated plants, we did not. Well, as we already discussed, the sand became darker and started looking more soil-like, more dirt soil-like. But the Muncher juice treated ones did not. No other weeds appeared within there, whereas the one that was treated with the Miracle-Gro had a number of weeds also came to grow within that bucket. So that was another interesting thing for us to see. And those plants right now, that was 9 months ago that we did that. The plants are still alive.
No, the Muncher juice is alive. The other ones are all dead.
Yeah, that's what I mean. The Muncher juice plants, yeah.
And the Muncher juice never got hornworms.
Right.
A huge piece of information that the insects did not want to eat that. And I think in reality, like, if we had been better at monitoring and watering, I bet you a lot more tomatoes would have come out of the Muncher plant, because he basically stopped watering it for months.
Yeah.
So that's why the flowers didn't turn to fruit, because there was no water for them to get the energy that they needed to finish off the fruit.
Right.
But again, very powerful information. The fact that you discouraged a pest from attacking, even though they were right next to each other. Typically, in that environment, those hormones would have spread right across.
Right across, yeah, and they didn't.
So they didn't. So just a huge indicator about everything that we're talking about today. That this really is, on so many levels, a phenomenon that we still have a bit more work to really kind of get all the answers out of it. And again, being able to work with Lannel and also the DNA work that we're doing, which we haven't got into yet, is really going to help teach us how better to use it. Oh, and what was the dilution rate too? We didn't even talk about that. You diluted what, 5 to 1?
In that case, we were doing we did 5 to 1 and 10 to 1.
Jesus. I mean, think about that. That's how powerful that little bit is.
Yeah.
Because with the Miracle-Gro, you add it to a certain amount of water. That's not to dilute it. That's to deliver it.
Right.
Whereas you can deliver it straight up, which
depending depending what we want to accomplish. If we're for growing plants, the Muncher juice without diluting it is kind of strong, and it'll I've seen it actually just throw plants into kind of a shock.
Mm-hmm.
But I started diluting it 3-to-1, then went 5-to-1, then went 10-to-1, and in all cases it's been working great. When if I want to rebuild just damaged soil, dirt, just straight dirt, then we can put it on just at full strength concentrate. So it depends what we want to do.
Yeah, and another thing too is that we did 2 experiments that haven't been completed yet. One is we sent Andy. This is Rhizos.sciences. She's our soil biologist from Lane Bingham's lab level, and we gave her a DNA stabilizer. So she took a drop, put it in the stabilizer, put a drop on the microscope, and then sent us a report. Now we have the report, but we don't have the DNA extraction yet because we need to do what's called not spike-ins. It's a form of 18S. So what you're doing is you're selecting for certain types of organisms. So flagellates, not just flagellates, amoebas, nematodes. It's the individual ones. I can't believe I can't remember the name of this. Anyway, once Craig has had enough time, because we pulled him off in so many directions. The poor kid's
I know.
But eventually he's going to get back into that research, or maybe we'll just start playing with the conversation with Lano, because they have the top lab in the world. So I'm sure they already have all of these primers, these different primers for specific organisms that have been proved. So because DNA is so new, a lot of work has been done to create these primers, but they have to be validated. In other words, they have to be repeated multiple times over and over and over again with the same result. That's how they have to finalize and say, okay, this is truly what it is. They can't just have 2 or 3 of these. They got to do it multiple times to verify beyond a shadow of a doubt, because this shit's really touchy. I mean, if you think about it, there's DNA in the air, there's DNA on me, there's DNA on my clothes, there's DNA on the floor, DNA everywhere. So you can get a cross-contamination without batting an eyelash, literally. So
it's very easy.
Yeah. So we, when we're working with Mr. DNA, he has some experience with these primers and did have some good intel, but he said, look, they're not all validated yet. And so I don't think you want to spend the money on something that someone could say, you didn't use a validated primer.
Yeah.
So, again, we'll revisit these things in the future, but to have that power, to have the direct microscopy and be able to overlay the DNA with the soil food web, that's going to be a really, really powerful.
It'll be a game changer.
Game changer, absolutely. So that's one piece of the puzzle. The other one is that we have a gentleman, Agro Row, Zach. I'm sure you've heard me mention him.
Mm-hmm.
We sent. I took a sample of Muncher juice from Agerman, put it in the stabilizer, and sent it to him. Or no, I sent him a bottle of the Muncher juice. But I took a sample, put it in the DNA stabilizer, and sent him the bottle. And then he's been taking samples every, times 2. So 0 hour, 24 hour, 48 hour, et cetera, et cetera. We're pushing 6 months now. In about a month and a half to 2 months, we'll hit the 6-month mark. And then he's going to do one more at year 1. And that's going to be an incredibly powerful tool for us to be able to tell the client, okay, you want to let this sit. You don't want to apply it right away. Oh, you're dealing with horrible soil, full strength, fresh as you can get. Because remember the experiments with the truncheon, we determined, we correlated the fact that as the EC goes down from 2400, 3600 down to 12 to 800 in that range, now we're getting high levels of protozoa. And those are the nutrient cyclers that we want to see in soil, especially if we've got plants, and not just bare dirt or cover crop or something like that. So again, like this, we're getting so close to some really powerful information as to how to push all of this forward. And I know I'm probably repeating myself to you, but I'm sorry, I'm really excited about this work, right?
I'm so
excited about this work. So let's back it up and let's talk about Agrimin for a minute.
Sure.
So you guys rolled in. We got Agrimin is the largest composter in the state of California. Very well, maybe the largest sole composter. Like there are other companies like BFI Waste Management. They're a giant hauler. They're a giant landfill owner, and yes, they do some composting. But Agrimin primarily makes compost. That's it. They're not a haul. Well, they do haul. Their sub company hauls it to them, but all they do is grind and produce compost.
Yeah. So
they have a typical commercial compost that has no biology. It stinks. It smells because the ammonia is still gassing off of it because it's still in the thermophilic phase. You put it on plants and it kills them. And this is a running joke at Agrimin. Like they go, oh yeah, the homeowner buys a new little fruit tree or an ornamental, and they come and get a bag or two of our compost. They mix it in and they plant the tree, and the tree dies. Well, they blame Home Depot or Lowe's. By the time they come back and replant, it's fine because the compost has been in contact with the soil that calmed it down enough so that it didn't steal the nitrogen from the plant. So that's crazy. That's how crappy this compost is. They also use it as weed control because it kills plants. So they'll go out and spray a field with the compost just to kill the weeds or keep them down until the next crop comes in.
Yeah.
And they've been getting a lot of calls in the last few years. I started working with them 2.5 years ago, 3 years ago, because they were getting calls from regenerative farms that wanted a decent compost product, and they have never been able to acquire that or accomplish that.
Right.
And the ones they did send out had really horrific problems. And so they stopped working with them because they didn't want to get themselves in a lawsuit.
Yeah.
So needless to say, we rolled in.
And we came in.
And dude, we killed it. Like we did 2.5 gallons per yard, 5 gallons per yard, 10 gallons per yard.
Yep.
And never went anaerobic. The 10 gallons per yard, we had protozoa in the 1 to 2 million.
The count, it was like off the charts. It was insane.
And nematodes, right? The T-Rexes of the soil. The T-Rexes can only live there if there's a complete ecosystem in place. So if you take under consideration, if you have 300,000 protozoa per unigram of soil, that is equivalent to 300 pounds of nitrogen being released over 1 acre over a 90-day period. That's way more than farmers put on. Way more. So, and this is a nitrogen in a form that's plant available, safe. It's not going to hurt anything. It's going to actually improve the bacteria, the existing necromass that's in place. So it's just, these kinds of things are just crazy. And again, being that it's a liquid, it's so much easier to install than a solid, because when you put the solid on the soil, the top half oxidizes, so you lose all the organisms. A lot of it blows away, so you lose the carbon. And what does sink in and penetrate is only in the top little bit, whereas you apply what we call dissolved organic matter or dissolved organic compound, it sinks into the soil. And so there's zero loss. It is the best delivery system for this type of work. So presently, and I think I told you this, but I might not have, it might have been wrong. I did 20 yards at 11.5 gallons per yard because of those extra totes that Gary brought me up to Peach Hill.
Oh, yeah.
So, and this time I did the test a lot more stringent. When we were at Agriman, we were at, if you squeeze the compost, it wouldn't really stay together. So it was, very low moisture content. And even under those conditions, it still worked.
Mm-hmm.
So at Peach Hill, I now take the soil, the compost, and I spend about 10 days to 2 weeks, it's a lot of work, building rice paddies because it's so hydrophobic up there. It's similar to Agriman's, but Agriman's is so green, it's so fresh that there's still a high level of moisture in there, so it can hold it, right? So up there, I get it so that it's chocolate cake. So I squeeze it, I can make it snowball, and I can throw that snowball at you. It probably would hurt, but it would break apart, right? But
exactly.
The goal is to try to find the upper bounds, like how, starting with a completely hydrophilic material, how much Muncher use can I apply before it goes anaerobic? Because at the end of the day, we need to know the upper bounds of how much we can apply. Because the stronger we make that compost, the further it'll go. Maybe you only have to spread a 1/4 inch and then water it in over the surface of the soil, or side dress, or what if you're doing tree restorations, like I do a lot of them. That we need that kind of carbony source along with the biology, a good delivery system, and then we chip over the top and water it in, so it slowly breaks down and releases that carbon. So I did 11.5 gallons, and within 4 weeks, we had high levels of protozoa and nematodes, which was great. I pulled the soil up and smell it. It smells like that earthy, forest inoculant, perfumey smell. And then after I finished that one, I started, this Sunday was week 3, and that was 15 gallons per acre or per yard on a 10-yard pile. And at week 3, which I just microscoped yesterday, you got it. It didn't go anaerobic. It smells great. And you've got the protozoa, you got the amoeba, you've got the tons of flagellates, and you got the nematodes. So we're still not there. And I have another toad that I'm whole. I have one for Kayla if we need it, because I don't know if you're going to be able to produce it. But either way, I'm going to sit on that one until Kayla's either you've made more or Kayla's been dealt with.
Right.
And then I've got one more to go, 20 gallons per yard, to see if I can find that threshold. And I'm just going to do like a 10-yard pile so I can keep some of it. So if I have to go to 25 gallons or 30 gallons, I've got enough to do it. And then I got 2 totes for Kyle Mote. Kyle Mote's been on this podcast before. He's a farmer in the Midwest. He's got 500 acres under care. We're going to be doing 100 acres of corn with a 20-acre left untouched as our control. We're going to be doing 5 or 10 gallons an acre. And we're going to have incredible data, because we're going to do Andy, we're going to do DNA. We're also going to do what's called nutrition at the end of it. I think we talked a little bit about the work that I did with it in the past. And when we used biologicals and had good growth rates, we had increased yields, increased what's called, or decreased energy, which means the animal has to expend less energy to convert that into nutrition. Had way less water, which is good because the animal doesn't need to eat water. The animal can drink water when it needs it. It's basically a filler. And the nutrients were at least 50% more, if not 100%. So we're going to get some great data.
And one of the things we can talk about here too, when we talk about water, water is a delivery system for the nutrients. Water is not in and of itself. Okay, yeah, the plant needs a certain amount of water, but the better the delivery system of nutrients present in that water, and the more readily available they are for the plant to use, and for the bacteria to have its effect, for all the other biology, that's where we become golden. And like you're just saying, less water is actually required.
Yeah. Let's talk about that, Mo, because you can cut your water for the
Mhm.
plant in half, 50%.
Yeah, and
some,
think of the the properties of the soil. The soil is now able to hold water because it's healthy. It's got the full biology. You can stick your hand down in it. You know, when we're at the farm up in Central Cali, you know, you put the shovel into the ground in this guy's soil, and it goes right in. You know, and again, just like you're talking about that the smell of the soil, you can put your hand right into it. You can feel it. It's great. And you know, that's, yeah, we're going to another level now again. But this is what soil used to be.
yep, yep. It's
You know,
called soil tilth and soil aggregates. And
yeah,
you're absolutely right, because now those aggregates act like little sponges and they soak up the rain.
yeah,
Or they let it, better yet, they let it penetrate so that it doesn't just run off and create erosion. And
yeah,
that's another, that's where those extra polymetric substances come in, because I know this gets a little bit deep, but they're basically magnetic or polarized. So they help pull things together and begin forming those micro aggregates immediately upon application.
mm-hmm.
And in some cases, like when we do pull the tomatoes and do the soil tilth, or not tilth, but particle size, or what I call textural test, I'll see if it's aggregated. But my gut
Mm-hmm.
feeling is, no, it's aggregated.
Mm-hmm.
And, for you to aggregate sand, again, shows the power of those extra polymetric substances, and their ability to convert what would be a desert into something that a plant can actually grow in.
Yep.
And he abused the fuck out of those. He said, I totally forgot to water. They're half dead. I'm like, well, let's get it. I want you to go out and look at it. And then when he started lifting up the plant and he saw closer to the ground, there were just flowers everywhere. And I'm like, how many flowers versus the Miracle-Gro? And I said, well, the Miracle-Gro's got 5, but this one's got 15, 20, 25, like
Mm-hmm.
10, 5 times more than the other plant. And again, if he had been a little bit more responsible or diligent and had watered it after we went through that process, then all of those flowers would have turned into fruit. Yeah. I mean, that's what they do. But because he didn't water it, they all dried up and fell off. So it wasn't a great grow trial. But we're between your gentleman up north and Kyle Moot. We're by I say end of year, because these nutrition tests take time, and everybody comes in at the same time. When the crops come in, then the labs get buried. So by the end of this year, we will have the level of data that is just undeniable. And remember the little arugula test I did?
Oh yes,
I forgot to mention that. Similar, we actually competed against myself, and you were better. And I do worm castings, fish brew, and compost, and I make a dissolved organic matter just like you, liquid form, and yours outperformed mine. Not huge, but I think it was probably 20%.
Yeah, because your stuff is still really high quality and really up there. So, yeah.
But the real interesting thing was when I combined the two of them, they worked way better, even to the next level. So that that's something in the future we're going to definitely explore, is when you fire up the bed, or as you're processing material, you're probably going to want to feed in some of this biocomplete compost or biointensive compost.
Yeah. And there's something really good to be said about that, because you have a really solid product there, and when you mate the two, you just create another product that is now you're combining them and getting the best of everything.
Yeah, and that's another thing too, is that another group we're pursuing is coffee, California Organic Fertilizer. They basically take a blood from chicken, which is considered a hazardous waste. It's impossible to anaerobically digest. It just coagulates in a mess. And this guy figured out a way, like you, Mo, through biological processes, to convert it into a stable 200, I believe it is. And when we were originally at the Seed Fest all together, I talked to both Jack, who's the VC that funded them, as well as their number two, and I was, explaining to them, I'm like, yeah, you guys, you have an organic fertilizer. Well, we have an organic we have a biological inoculant, and if you combine those two together, your fertilizer is going to be way, way more valuable than it is without the biology in place to speed up the process of distributing it. Because we don't care if it gets consumed by the bacteria or consumed by the plant. It doesn't matter. It's in the pool. It's in the root zone. It's in the rhizosphere. So it'll be utilized way more effectively and efficiently based on what the plant needs and wants. None of it's going to run off. Doesn't matter how much water you throw at it. It's all going to be bound up and tied up in a long release or short release, depending on what the plant wants. The plant's in charge.
Well, and that's another really big, important issue I think that we could address. To go back to the NP and K issues, the chemicals that are used in such high amounts. I mean, I'm going to guess here that, let's just say, for example, if you have to put like 100 units of nitrogen into the soil for maybe 20 to actually get used, right? Something like that, and but you're burning the soil. You're just stripping it when you add these products. Now, one thing that we could probably touch on here is when we take the bioactivated fertilizer product that we are generating, we've taken the variety of organic material that we've processed. It's been broken down. All the good stuff that's in there has been consumed, is eaten up by the bacteria. You've got your elements present within that bacteria. The protozoa and everything eat that bacteria. They poop the stuff out. All these amazing things happen. The bacteria itself can get taken up into the root systems of the plants, cause non-legume plants to act like legumes and fix nitrogen in the soil. There's just one amazing thing after another going on with this. So maybe we want to just touch a little bit on that, where not always necessarily that we're not as high in like the NP and K as the chemical applicants are, but maybe we want to talk a little bit about how much more readily available all of those nutrients are with our process.
So that was another really interesting attribute that came out of Agriman, was just how much organic nitrogen we bound up in the compost. So we didn't add per se nitrogen. We added biology to their compost, and we converted their targeted compost, which they very rarely hit, openly admit, but they use that as their strong arm. They use that as like, well, this is where you have to be. We were way better than that, and that was in the lower rates. Like we never got the 10 gallons. Oh, I think we did. That's right. DC confused them. We did actually get the 10 gallons per yard measurement, and that's the one that was double over the competition that they used or they pinned us up against. So again, it's like the ability to store this stuff in a way that's non-mobile. It can't go anywhere. It is incredibly valuable. And there was something else. Oh, it's important to have an understanding about synthetic nitrogen, right? If it's a nitrate or it's an ammonia. So if you're using like an ammonia sulfate or any one of those ammonia nitrates or ammonia-based product, it requires a lot more water for the bacteria to break the ammonia up and consume it or release it in a plant form. So either you got to use a ton extra water, or if you're using a nitrate-based fertilizer, the bacteria have to consume carbon as an energy source to break that nitrate down to make it plant available. So you're either burning carbon or you're burning water, but both of those create compaction. And the more compacted it comes, the more the soil life dies, because if the air can't get down, if oxygen can't get down to the bacteria, they cyst, they go to sleep, they can't help it, or they die. Right.
Well, and another thing we could talk about too, when when you're watering, you have to put all that extra water in. What happens to that water? How deep does that water go into the ground? And now you're oversaturating. Even though on the one hand they say, oh, well, you need all this water. It's like no, you're watering too much, and think of the damage that happens from that. And that's something that again we're seeing the results from. You like again your like your root nematodes and stuff like that will become present in that kind of environment. And what do you end up having to do? Well, now you got to use more chemicals to kill that stuff, and then you're destroying the land again, and you're destroying the biology that we all want to restore. And it's a vicious cycle. It just keeps on rolling. So you need to water the right amount, which I think as we're working more and more, we're going to see is substantially less than what is actually being done right now.
Yeah, and I think that where you're really going to kill it is when we move into synthetic run farms, because your gentleman up there now has been moving into regenerative for quite some time. If you can stick your hands in the soil, that he's got super healthy soil. If it smells that good, it's super healthy. And he is all about the biology. And he's already had effect. He's had positive effect. And I know you don't want to get too excited, but when you told me that, I got excited. I'm sorry.
And believe me, I'm excited too. It's just that we're just in the beginning, so I want to run the cycle,
Yeah,
I know. It is pretty amazing.
I know it's going to happen. I know it's going to happen. It's going to fucking explode. But anyway, so yeah, and you hit the nail on the head. Is that like you're creating this downward spiral? So the more you water, the more it's going to push that nitrogen down and pollute the groundwater, or the more it's going to compact and run off and create erosion. And the exact same thing is going to happen once you gobble up the carbon. There's nothing to hold the soil together. It turns into dirt that's highly compacted. I mean, that's all the work I ever do is I don't get handed nice jobs. I get handed fucking dirt.
Sure.
And I'm told, well, my trees are struggling. I need, why is my landscape dying? Well, you over fertilized and you overwatered, and you never added compost. You never added any carbon back in. Yep. So again, at the end of the day, to have not only have you as a good friend, but an asset and have access to that material on scale is going to change. If we all don't get assassinated along the way, you're gonna disrupt so many industries. It's not funny, right?
Let me just say for the record, I am not suicidal.
Yes, I'm not suicidal. If I end up with a suicide claim on my desk, you know where that came from.
Oh boy.
Unbelievable. Fucks up day we have to clarify that and claim it publicly, right?
I know. Hey, but here we are.
All right. So typically at this point, I usually go to questions, and I'm surprised that we don't have more questions, but that's probably because we've done a really good job explaining it, between you walking us through the machine, explaining the different components, talking about the variables that we still have to figure out.
Yeah.
There's, we can only answer such a level of question, but Ken, why don't we go ahead and hop on and hit these 2 questions and see where that takes us?
Sure. Sounds good. Peter Cactus, what kind of waste goes into that bad boy?
Oh,
that's a great question. Mo, everything you've ever put in there, talk about it.
I don't see the question. Oh, what kind of waste goes in? Okay, yeah. You know what? My screen is frozen up. Can you guys hear me okay?
Yeah, we can hear you fine.
Okay, great. So what kind of waste goes into the muncher? Every kind of organically derived waste, food waste, plant waste, animal waste, everything. Any organically derived material will process in the muncher. I did mention like lemons, for example, citrus in general, but lemons in particular. Some things have to go in a smaller quantity or ratio, but every type of organic waste will process in the system.
Mo, what about the carcass? Talk about that for a minute.
Oh yeah. So years ago, this goes back into 2009 when I was first experimenting. So I took a goat carcass and I put it in the 30-gallon unit, and this was still earlier, biological mixtures and things, but by the morning of the next day, the carcass was completely dissolved. It was broken down, gone, bones and all.
Mm-hmm.
That's pretty expensive.
How about plastics? Have you guys?
Plastics don't rapidly break down, but we can take a certain percentage of plastic can run through the system, and it although it doesn't break down, it's not harmful to the process at all. And I do have some bacteria in the mixture that actually accelerate the degradation of plastic. So if the plastic itself, it'll get kind of shredded up within the maceration grinder pump, and it'll just run through the system. It'll end up acting kind of like a perlite, vermiculite type of product, and it can stay present in there. One of the things that happens with the plastic is that it will degrade in nature once it's been inoculated with the bacterial mixture. So you take that, you put it out on the ground, on the soil, it's going to break down faster than it otherwise would, because plastic, depending what kind of plastic it is, it can take months or years to break down, but it'll happen much more rapidly if it's been ground up and inoculated with our mixture.
And I'd love to add a little something to that. I've been reading a lot of articles. Talked to a gentleman we had on the podcast. I think it was last week. The vermicompost gentleman who was that's taking plastics and converting them into worm food with biology. So he is actually breaking the using his specific or proprietary blend of bacteria to take those very complex and difficult to break down plastics, not the easily compostable plastics, but the really tough ones. And he breaks them down once into a more suitable form. Then he adds in a polymer of some kind, again, proprietary, and then takes that slurry, or that jello as he calls it, and throws it in his worm bins, and it's gone. It's been eliminated. So, he's one that I'm going to stay in touch with, Mo, over the future. And at some point, I'd love to connect you guys, because I think that there definitely could be some synergy, because I keep forgetting to tell you this, but I've been taking, like, after I did the 11.5 gallons and the 15 gallons on the test, there's always the solids at the bottom. You know what I'm talking about, right? That's stuff that I can't even pump. Like, I'll pump it until my pump starts to really stress, and then I'm like, okay, that's it. There's not enough liquid.
Stop, yeah.
And so I took that and I put it on my skid steer and I strapped it, and then I went over and kind of dumped it into my worm bins, and I created this like cake, it's. I think you've probably seen it. It's like solid. I mean, you can pull it up and break it apart, but it creates this like fabric, for lack of better words. Underneath that, oh my God, the worms went crazy. Absolutely nuts in that. So again, a substance that is super friendly to bacteria, super friendly to worms, and would help support, a large scale vermicompost facility. Well, that's what he has. So the synergy between microplastics and worm food, and then potential muncher solids to speed up or support what we call worm orgies, because that's really what it was. It was a worm orgy. It was a mating. They were all balled up together, doing their thing.
Yeah.
So again, there's so much going on, Mo. I hope I'm. I try to remember to tell you everything I'm doing, but
it's overwhelming, believe me. Even just the work we're doing up in Central Cali right now. I mean, it's just it's all consuming, and now here I'm going to be gone at this Waste Expo, for a week, and then it was just like, oh, so I have to put the muncher into low power mode, and we're going to have someone up there just testing the machine regularly to make sure everything is running properly. But it's there's so much to do, and as we process more and more of this material, I processed a little example of that we are playing with up there, pomegranates. And pomegranates, I did a little research on there because I did notice that it affected the biobed when we started processing them. And it turns out pomegranates have, similar to lemons, they've got some antimicrobial and antiviral properties. They're very strong antioxidants, of course.
Yep,
but interestingly, they're not highly acidic like the lemons, and they also have a lot of nutrients that the bacteria love to eat. So we had kind of dueling properties going on with them. So the biobed came down, but it didn't crash like it did when we had a high concentration of lemons. So that was an interesting thing to work with. So now we're going to do some more, because they have a huge issue with being able to dispose of pomegranate waste when they extract the juice, the components, and everything. So they've got peels, they've got stuff that might be rotten or rejected or whatever form, and they have a big problem. How do they get rid of it?
And that goes back to Agribin, when they will take those lemons and just push them into a compost pile.
Right.
But it shuts the thermophilic process down, so they're not reducing. It's tying up yard space. And you prove that you could, at some level, deal with them, because they can't. Right now, they can't deal with them. They're struggling to figure out a way to get rid of them, because the bottom of the pile goes super anaerobic, stinks like hell when they open it up.
Oh yeah.
And the top just sits there because of the pH. It's too low. So, and another thing that was really interesting, back to Perpetual's question, was tree products. Like, so you were taking, we call GOM, ground organic matter, 3-inch minus, big, chunky, nasty stuff, and threw it in that grinder and shredded it up, and it turned it into, this incredibly wonderful fibrous thing that is like that mat. It created like a fabric almost.
Yeah.
That was super beneficial. Like if you're dealing with trying to decompact soil and you have a fabric like that you could plow in, oh my God, it's going to be like an interesting, instantly built haven for biology, for air infiltration, for water infiltration, for water storage. So the limits on what this thing can take, there is none. I mean, I don't want to get ugly, right? We could, but I mean, you guys ever heard of Soylent Green?
Well, one of the things that we can talk about as far as the muncher itself is that we can tailor a system to a client's needs to a degree. Say, okay, we're going to be grinding more wood, and that's mostly what we're going to be processing. We don't want to process just wood, but we can, if we say, okay, we're going to be processing mostly berries, we're going to be processing a mixture of waste. We're going to have some food waste, some green waste, some all these various different things, animal waste. So we can do different things. We can have different kinds of grinding systems, pumping systems, all these things. And the core, of course, is that when it's in the digester and we're cycling the bacteria-rich liquid, microbially rich liquid, I should say, and biology rich liquid, that is just continuously cycling through there and maintaining that reaction. But we can have different kinds of delivery methods depending on what kind of waste we're processing. So just to go a little further with that question that he asked as well, when you're saying what kind of stuff can go in, it's like anything.
Well, another thing that we found out that was really interesting, that Agribin's required to go through what's called post-pathogen reduction or program. Right. So what that means is they've got to hit 130 or greater 5 times over 10 days.
Temperature-wise, yeah.
Yeah, and turn. And so that's to get rid of pathogens. Well, when Gary, who's part of the team that usually works side by side with Moe, got a little crazy and ran over to get some fresh GOM that had not gone through PFRP. Came back and fed it in there, and it was butter. So it actually liked those plant juices. And I'll be willing to bet too, because we did come out pathogen free, that those pathogens were just yummy little desserts for the bacteria that we had in the bed. You know, again, biostimulant is a food source for somebody.
Oh yeah.
And you know what? And in all seriousness, when I said Soil and Green, I meant it, because there's already human composting happening. Yeah. And it's a huge fucking problem, because they're like, well, you know, how do we do this? Because we can't just bury you. You're going to smell, or you're going to, you know, cause us problems. We can't embalm you. So it creates a real problem. And personally speaking, I want to be composted. I've told all my kids, do not put me in a concrete fucking chamber. I want earthworms and bugs. I want to be reborn back into the soil the way we're supposed to be as humans. And so to take one of these machines and set it up at a funeral home where the person wants to be composted, does not want to go through that whole burial bullshit, you know, that the church put on us. It's just another avenue for this. For handling, I'm sorry, biological waste. Yeah. You're not killing the spirit. You're not killing the soul. You're just getting rid of the old vessel, man.
Yeah, absolutely.
So again, I got a little dark. I tend to get a little crazy at times.
Yeah, just a little late, just a little. But that's really important to understand, is we are just a bag of biology, and we weren't designed to not go back into the soil. We get all the nutrients from the soil because we are soil. But
yeah, and we're designed to carry on the next generation of biology.
Yeah. Oh yeah.
So we'll go to the next question here. So, are the end results always slightly variant in DNA strain nutrient levels?
Yeah, the depending. I'm assuming here we're talking about, okay, like depending on what we feed into the muncher, do the results change with the output? So I'm going to take it from that standpoint. And yes, it is going to vary. But what we have found is that no matter what we feed the system, we get a quality product coming out of it. It will vary, and we're going to be determining that with further testing. But yeah, it is going to vary in its quality somewhat, but we always get something that is a very viable product coming out at the end, no matter what we have fed into it.
In other words, they get plant reaction, positive plant reaction.
Yeah.
So, you know, again, in the future, tailoring the inputs based on the crop they're being applied to will be a valuable and analyzed asset. But at this point in time, and eventually too, biology, you know, what Mo's adding in, or you know, other ingredients that he's adding into the system, you know, it's targeting this specific plant, tree, whatever. Right. That'll all be taken into consideration. But you know, that foundation of all of that is, you know, back to natural farming is, you know, use the plant that you want to grow and feed it that plant, because it's already taken all the energy to build the biomass from the sand, silt, clay, and organic matter. So why wouldn't you use that to feed the plant? It's going to save the plant a tremendous amount of ADP, which allows higher yields, greater strength, blah, 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 blah. The same shit I preach all the time.
Oh, yeah. Well, and another thing we can talk about, too, is that not always that we get a higher yield, but what if even if we were to get a lower yield, but it takes us substantially less resources to produce that, you have a tremendous savings and increase in profitability in that kind of case as well.
Mo, that's a great point, because this is something that I tried to teach landscapers, was if you go with a compost tea or extract, you're not going to have to cut the lawn as much. The lawn's going to be healthier. It's going to be more resistant to drought. You know, it's not going to have the weed pressure that you typically are used to. And they all look at me and they go, okay, fuck you. They want to fertilize. They want to grow it. They want to cut it. They want to use their herbicides. That's how they make their living.
Right.
But I'm trying to teach them that they could take on more lawns. They could do more work and make more money because they're using less time and energy and wasting it on products on the properties that they already maintain. And everybody's going to want them because that lawn's going to look so much better than their neighbors.
And
but
it's going to be consistent.
Yeah, but that's the problem with humans. They can't put one and one together. It's always, hyper focused on this. This is what I was taught. This is what I do. Yeah. And not like, oh God, I'm killing myself. I'm exposing my children and my wife to cross contamination because I come home with the shit on my clothes and it goes in the washing machine, spreads to everybody's clothes. They don't think about that. They don't think about the responsibility and the side effects of their practices. And so, I mean, how many bald landscapers do you see? Seriously, pay attention to it. A lot. Yeah. A high majority of them. Anyway, was that the last question? Oh, he did touch on DNA. So yeah, the DNA work is going to be extensive and probably throughout the next couple of years before we can come back and really say, this is what we know. This is how we've improved the process. This is how we've improved the output. And these are the wonderful things that we're accomplishing as a result of learning how these individual species, families, and communities are working in unison together to create these processes. So that's going to take a little more work.
That kind of leads us into when might farmers and gardeners, et cetera, be able to access this product?
That's the testing that we're doing up in Central Cali right now is going to help us determine that. There are certifications that have to be done, and right now we're doing tests and trials and things, but we can't just go and sell the product right now. We will be doing that, hopefully very soon. But that's that part of all the testing that we're doing right now. This is what we're working on, is to accomplish that.
And I think that the other problem is California. The regulatory is just. I mean, Kyle Moot can do whatever he fucking wants in Ohio. So as long as we're selling outside of California, that very well may happen, next spring because of what Kyle's doing in his area. Because Kyle again is a at least third generation farmer, and he's been known to be experimenting for 5 years now, and so there's a lot of eyes on him, checking out what he's doing. And, like last year or 2 years ago, all the plants in the drought, they were in a drought, and all the plants, all his neighbors' plants, anything that was NPK turned gold real quick, and his were still producing beans and flowers while they're. So they're noticing that this biology or biological, stimulants or inputs or whatever are making a difference, a significant difference against NPK. And the fact that NPK has continued to spiral upwards is only putting further pressure on the farmers to look at new avenues to grow it. So I tend to believe that in the spring of next year, it'll be sold in other parts of the country without a problem. It'll only be California that, hey, maybe if these guys, partner up some way with coffee, California Organic Fertilizer, they can skip stone, so to say, across the regulatory bullshit because they've already had to go through it all. And I know Ron's got some connections with lobbyists that could help, kind of navigate some of that nonsense. But we'll have to wait and see. California's going to be a bitch, though, for sure.
Oh yeah. I see another question coming up. If someone wants to trial the product, so basically, like I said, right now we have to be a little careful about it. But if someone does want to try it, contact us. Go to our website, ecospheresciences.com. You can shoot us an email from there, and we can see if we can get you some product to try, or what we can do. We do have to be cautious about it, again, because we can't just go and just start giving it, to the general public yet. But we'll be happy to see if we can accommodate.
And you can also hit up me. Like, I know these guys are really busy. ecosystems is building.
Yeah,
they're building a ship right now. It's like fucking Noah's Ark. So, if they can't get back to you quick enough, hit me up, and then I'll navigate the way through ESS, whether it's I take the liability, whatever. I don't care. I've been playing with this stuff long enough to know there's nothing to worry about this.
Oh yeah. We know it's safe. We know it's good, but yeah, there are issues that we have to deal with, unfortunately.
Yeah, protocols.
Yeah.
They have
how much material are you getting? Like, say somebody does want to trial it, and you guys say yes. How much material are you guys making right now?
What I'm doing right now is I'll probably be producing 500 to 1,000 gallons a week.
Mm-hmm. And that goes a long way at 1 to 5.
It does. Or even you can take it up to 10, dilute it by a factor of 10. So there's going to be a reasonable amount, and depending what you're applying it to, again, if you're just doing a small test project like we were doing in the 5-gallon buckets with the tomatoes, you're using a very small amount of the juice for that.
Mm-hmm.
But
I just want to use it on my lawn.
Sure. And to do a lawn, you're talking like, let's say however big your lawn is, but let's just say an average home lawn. I mean, you might use a gallon
in a whole season.
Yeah,
possibly. Yeah.
And just to verify too that this product is actually being sold in Mexico, right?
Yes, we are actually selling it down there. We're doing. We have our partner down there in Mexico City has a a system running that he's generating the Muncher juice on a daily basis, and he's already started distributing it down there.
And having incredible success, farmers coming back.
Oh yes,
he's going to raise the price soon. I mean, and we don't have to get into numbers, but it's still so cheap compared to everything else, but
right.
So profitable if you look at it. And again, it gets to the point where you could maybe even get to the point where if you create the demand, you can pay for the food waste. You can pay to have people bring it to you, and then give them a bottle of Muncher juice and pay them. Right.
Yeah, and I think we didn't really touch on it too much here, but we're accomplishing two things. We are diverting organic waste that could otherwise go to landfill, like here in California, we are going to supposedly have to stop doing soon. That Bill 1383, but we're taking that waste, and like Los Angeles alone generates like 2,000 tons of food waste, organic waste a day.
Mm-hmm.
I mean, that's an incredible amount to have to dispose of, and they're putting through the legislation here right now that they want all of that organic waste to no longer go to landfill, which is already a thing that they're trying to implement, but they want it to go to anaerobic digesters. We don't have enough anaerobic digesters in the state to handle even a fraction of the waste that we generate in the state. So how are they going to do that? Obviously the Muncher is a solution. But there's going to have to be some changes is really what it's coming down to. And I think people are starting to see that and understand it. Again, the farmers that we're talking to, people here in the cities are just going, this is too much.
Mm-hmm.
It just, and when it goes to the landfills, there's just always problems with it. It leaks, it stinks, it's dangerous.
Yeah.
Think of and Leighton could tell you, the temperatures that are reached when that stuff gets down at a certain depth and compaction, the organic material. I mean, it can get up. I think it gets up over 1,000 degrees, doesn't it?
Something astronomical.
It's crazy.
And it's affecting the pH. It's affecting the groundwater. Yeah, they're putting liners down. Yeah, liners last time.
They leak.
Yeah, come on, they leak. They get full holes. They disintegrate. Especially in those environments, right?
Yeah.
And that's nothing to say to the methane gassing off. Methane, we complain about CO2. Are you fucking kidding me? The higher the CO2, the better. But
yeah, CO2 was wonderful stuff. But it's methane is really interesting. I know we're running out of time here, but methane is wonderful as a fuel. When you burn it, it's super clean burning. but methane just on its own going into the atmosphere is so nasty. Yeah, and people don't really pick up on that. CO2 is plant food. We need lots of it. It's great stuff. Go to any greenhouse. What are they doing? They're pumping carbon dioxide into that greenhouse to grow the plants. It's great. But the methane and other toxic gases that are just poured into the atmosphere through these processes, that's where we need to do something.
The methane will kill the plants.
Yeah.
Not make them grow.
So one really quick question, and then we got to stop the show. But how great would MJ work with Fish Brew, Leighton?
Hell yeah. Again, this is something that when ESS calms down or gets into a place where we can kind of splinter off and spend more time focusing on some of these other questions, like adding compost, adding worm castings, adding fish brew, as further inoculants to Moe's work. We already know, we've done it. We've added some of my complete product at Agerman. No effect in the biobed. I couldn't really tell if there was a difference in the compost because I would have needed DNA. Direct microscopy wouldn't give you a straight answer on that.
Right.
But my gut feeling is, again, through horizontal gene transfer and biosymbiosis, that you are having evolution that's occurring. We could be making Moe's bugs stronger. His bugs could be making our bugs stronger. But they all play nice. They all play well in the party.
Biodiversity.
Yep, biodiversity. and at some point, too, in the future, ESS is probably going to start making smaller machines that can not only support that kind of research, but get them into independent hands all over the world, right? Mm-hmm. So, it's a beautiful time to be alive and hanging out with these guys. They're all really good people. And it's a dream come true for someone like me whose goal is to regenerate as much soil as I can before I get popped. I did not commit suicide.
Exactly.
Okay, guys. Well, I think we should probably end it here. Moe, thank you so much for coming back. I can't wait for the product to go to the next levels, especially with all the research that's coming out. Leighton, last words, brother.
Oh, thank you, Moe, so much for coming on and
thank you.
My pleasure. 2 hours of your time and updating the crowd and Ken on what we've accomplished. And if you think about what we've accomplished in the last 2.5 years, it's a lot, dude. It's really has, really unlocked a lot more of the what is this phenomenon. Yeah. And Ken, thank you so much for all the time and energy you put in behind the scenes and to manage the podcast.
Yeah. So. Very much appreciated. Thank you, Ken.
You bet, guys. As for the channel, Wednesday is Andy and myself. Thursday, we may have everything figured out on the back end for the ladies coming on. That is going to be a show coming up. They're going to be doing 2 shows a week. So that's coming up as well, guys. But everybody have a wonderful day. I'm waiting, Moe. I want some product sooner than later, but guys,
we'll figure it out.
We'll see you soon.